Previously, we have seen that outlier detection and removal using standard deviation and z-score. Now we are going to see the outlier detection and removal with the help of IQR. Now a question might arise in your mind that what is this particular IQR? So IQR is nothing but it is a concept of interquartile range. It is used to build box plot graph. The idea is simple. We divide our data into 4 parts. Here you can see this image I have taken from Wikipedia and it is quite insightful. And each part is a quartile. That means this particular part, this part and this part. Each part is a quartile. Now IQR is basically the difference between the third quartile, we can say Q3, that is 75%, and the first quartile, that is 25%. This is basically IQR. Now with IQR, outliers are defined as observations, that is below Q1 minus 1.5 into IQR. This will be one observation, and above Q3 plus 1.5 into IQR. That means these particular range and these particular range. So this is what we are going to do, and we will divide the data into 4 parts which are there, and each part is the quartile. This is the brief which I want to give you about IQR. Next, what we're going to do is, now we're going to implement it with the help of code. So here you can see that I have imported pandas as PD, and I have made this particular CSV file of name and height respectively, and that I have displayed you. This is the file which I am reading, and I have uploaded it for the current session storage also. Here you can see in the same path I have given in the read CSV. Next, what we are going to do is, we have seen the file and now we will be firstly using describe. The describe function we will be using, and for that we can write df.describe. And as I execute the cell, what happens, you might know this, the count, mean, standard deviation, minimum value, 25%, 50% and 75% and the maximum value we get out of it with the help of describe function. Now we need to detect the outlier which are there. So for that we are going to use a height, df height. Q1 will be the 25%, so quantile 0.25, and Q3 is the 75%, so that will be quantile 0.75. So what you have to write like this, Q1 is equals to df dot height dot quantile, and here you have to write 0.25. So this will be the first quartile which is there, and similarly we're going to make Q3 also, which will be same df dot height dot quantile, and this is 75%, that tends to 0.75. And then what we need to do, I will print both the Q1 and Q3 which is there. So for that you can simply write like this, Q1 comma Q3. And as I execute this particular cell here, you can see that Q1 is 5.125 and Q3 is 6.475. This is there. Now we need to find the IQR, so that is the difference between them. So I have to write like this, IQR is equals to Q3 minus Q1 which is there. This will be the IQR, and when I execute this particular cell, then I have to write here for printing the IQR also, that is IQR, and now we're going to see the output, that is 1.34 something is the IQR. Now what we need to do, we need to set a lower limit and upper limit, and then we will find the outliers only. So this will be our lower limit that I am writing as LP, let's say, and LP is equals to Q1 minus 1.5 into IQR. Two things which we need to find, we check also while I was discussing the theory portion, and the upper limit which will be there, that I am writing as UP is equals to Q3 plus 1.5 into IQR. These will be the two sets of value, and then we can display both the values also as LP comma UP. And here you can see that the lower limit we can say is 3.10 and the upper limit is 8.5, which is there. Next, what we need to do, we need to find the outliers which are there, and that we have seen also previously for standard deviation and z-score, that we write like this, df, and here we firstly check with the height lower limit and then the upper limit, and then combine them with the help of pi. So you can write like this over here in the parenthesis, df dot height, and then you need to set LP less than LP. You will mention a pi, and then again df dot height, and then you will mention which is the UP. So UP must be greater than the height greater than UP. You have to write like this, the upper limit which is there. And as you execute this particular cell, then you're going to see a data frame which is there. So this is the data frame which is there. Now we need to remove the outliers which are there. Outlier needs to be removed because this is a set of value which is not useful, this particular height 1.2. So we need to remove this outlier which is there. So for that we will create another data frame, that is df1 equals to, and then what we used to do is to combine both the values and print this new data frame, and then we used to check the shape finally of df1 and df original data frame which is there. So for that you can write like this. You can copy this cell of the lower limit first, and you have to write it here. And now you're checking for the rest of the data frame, so you have to change a few things. This is how you have to write. And as I execute this particular cell, then you can see here, now this data frame doesn't has this particular value, it has been excluded. Now what we need to do, we will check the size of both the data frames, that is df1 dot shape. When I execute this particular cell, here you can see that it prints 13 and 2. There is the name and the height which is there. And you can see that 13 set of values are there. We can say the data points. And if you want to check of the original data frame which is there, then it is simply df dot shape, and that tends to be 14. That means one value has been excluded, removed, that is an outlier, and that is this 7, ln and height is 1.5. This data point has been removed. So by the end of this video, we have seen that what is IQR, what are the percentages required for it, how can we detect the outlier and remove it with the help of IQR.